Good morning, everybody. My name is Patrick Grostet. I'm a technical marketing engineer for the IoT business unit. I will be the speaker for the session, which will be focusing on all the technology about cellular, how we use it on our industrial routers. So it's a mix of market trends as well as configuration. The session is 2585. So I'm assuming you're already familiar with this slide. Remember that we are monitoring the session. If you have any question, join the WebEx team space, and I will be answering questions. You can also go for the meet the speaker later if you have any question. But I'm pretty sure you already know that. I don't know how many of you have already been to a wireless session, because we had several of them during the Cisco Live. What is quite important is when we are considering industrial IoT, wireless is clearly playing a key role. The challenge is when you go wire is quite simple. You go legacy serial, RS-232 or RS-485, or Ethernet, and you have different, I would say, Ethernet speed. But as soon as we go wireless, the question is, okay, which technology, what is the data rate, what is the spectrum, and what is the use case? And that's quite important. The key point is you don't have a single technology today covering all the use cases. But the fact is, whatever your vertical, utility, transportation, manufacturing, connected road or whatever, wireless is becoming more and more important. And that's the reason we have different sessions during the Cisco Live track, and this one is dedicated to cellular. So what is the agenda today? I want to review the evolution of the cellular technology itself. From there, how we implement it on the Cisco iOS routers, how do you configure it, how can you troubleshoot it as well, and then next, a couple of recommendations regarding design guideline. So let's start with the technology. The fact is, cellular today is everywhere. I'm pretty sure you are all using cellular on your mobile phone. But for the industrial IoT, as soon as you have a remote location and you want to connect the remote location, obviously cellular is becoming, the obvious choice. The fact that today we start talking about public services, you are getting cellular services from your service provider, but we're also getting now private cellular, meaning you may want to deploy your own cellular infrastructure, like manufacturing, like a stadium. So that's the way we look at how it will apply to the use case. And as I say, clearly I can take any of the vertical here, and I will find an application for cellular technology. So let's do a quick review of the evolution of cellular. Because one of the challenges is cellular is not a single technology. When we say Wi-Fi, you're already familiar with Wi-Fi 5, Wi-Fi 6, 6E, 7 in the future. But the evolution is exactly the same with cellular. We started a long time ago with a 2G, and 2G was mostly how we could put the analog voice, and then 3G, and 4G. But even when you start looking at 4G today, you have multiple iterations of the 4G technology. And that's the way, you will see later when I'm talking about the Cisco pluggable interface, you will see different category. Different category of speed, different generation of the technology. And now we are talking about 5G. And even for 5G, you can get 5G services from your service provider, but we have two flavors of 5G. The first one is what we call non-standalone, and I will come back on that. It's clearly the kind of services you can get today from your service provider, and it's a smooth evolution of 4G to 5G, how we can take a service provider, making sure that they can leverage what they have today for 4G and add additional channel and frequency band for 5G. And then we have the standalone mode, or SA, which is clearly, if we say private 5G network, it means, at least to me, a 5G standalone deployment. So that's clearly what we see. The fact is cellular run over license band. If you want to look at all the spec, it's coming from 3GPP organization from a standard standpoint. You're running IP on top of it. As I say, you have different flavor. So if I look at unlicensed band and unlicensed technology, at the high end, you have Wi-Fi. At the low end, this is where you find technology like LoRaWAN, You can wireless ART ISA 100. But here, when I look at 3GPP specification, they have defined technology like narrowband IoT or LT category M1, which is a low data rate of technology. So once again, when we say cellular, it's not a single technology. It's a variation of different technology over time. And at the same time, the fact that as wireless, well, the foundation of wireless is spectrum. And if I start looking at spectrum, you see evolution in regulation. So what does it mean here? Most of the time, you get spectrum for service provider. It's nationwide, and you can get multiple frequency band for that. But when we start looking at private deployment, you may have what is called locally shared spectrum. What does it mean? It means there is a frequency band that is allocated to private network. You can acquire it, and it will only use locally for a given area to cover. Like, for example, is that 1 square kilometer or maybe more. And from there, this is where you can start deploying your cellular technology on top of it. So let's review the spectrum. Yeah, let's review the spectrum. The way we can classify spectrum, and whatever the technology, I mean, it's independent from cellular, you can say you have 3 categories of spectrum. The first one is clearly the sub-gigahertz band. Whatever it's, most of the time when you look at cellular, it's 600, it starts at 600 megahertz band. In Europe, it's more 700. But today, what we can see, and I have a few slides on that later, we see country also using the 450 megahertz band for LTE. And when we say sub-gigahertz, it means long coverage, good penetration, but most of the time, low data rate. Remember, if I look at the, you can look at licensed or unlicensed and see what kind of technology is using that. If I look at unlicensed, it's clearly technology like LoRaWAN, where the maximum data rate is 5.4 kilobits per second in Europe. Or you can look at the LTE 450 and the LTE, the 700 megahertz band, where we'll see that with the channel bandwidth, we are not getting more than 30 megabits per second. But as I say, low data rate, long penetration. What most of the people are using today is the 1 gigahertz to 7 gigahertz band, which means the mid-range, where it's a good compromise. We can get good penetration and good data rate as well. Now the question is, how much channel bandwidth are you getting? Today, if I look at most, the LTE, service provider are deploying 20 megahertz of channel bandwidth for the band. And if you want to increase the data rate, what you do carrier aggregation. And I will show you a slide of carrier aggregation. Now, one of the benefits moving to 5G, the frequency band for 5G, once again, it's running on the same space. That's the reason many service providers in Europe or around the world, they are turning off 3G services. And the reason is they want to get the frequency band back and be able to use it for 5G. And that will be the same for 2G as well over time. So what we see here, once again, you can see licensed and unlicensed. Unlicensed band, Wi-Fi, typical technology using the mid-band, and cellular, that's what you use today for 5G. And then there is the new IN, what we call above 7 gigahertz band, on cellular for 5G is what is referred to millimetric band, and this one, they are not yet well deployed. If I look at Europe, only few countries so far have done the auction for the millimeter wave band. It will give you very high data rate. When you say, for example, 5G will be able to reach 10 gigabits per second, it's clearly on the millimeter wave. But it doesn't propagate very well. So that means maybe a few hundred meters and no more than that. So once again, the benefit is when you start deploying cellular technology, you can combine all the band and start getting more bandwidth and different type of coverage. And as I say here, it's purely how you handle the spectrum. And you can see on the slide, it's licensed or unlicensed. So it's not one technology being better than the other one. It's just the law of physics for the frequency band. So if I give you, I would say, just to put some data on the spectrum allocation, let's take 5G as an example. And you see here the frequency band allocation around the world. So on 4G, you may have been used or I'm using, my service provider is using band 7, a band 20 or 28 or whatever the band you have in your country. For the frequency band on 5G, there are numbers starting with N. So it's N1, N2, N3, N7. And if I start looking at the new mid-band, which is normally the 3.4 to 3.8 gigahertz band, this is known in Europe as N77 or N78. So that's the kind of services you will see later in the example of configuration the service provider are deploying. And then there is new number, whatever is like 259 to 60, it's millimeter wave. So if I look at the 5G spec, you have two kinds of frequency band, FR1, which is sub-6 gigahertz, FR2, which means millimetric band, the millimeter wave. So, as I say, I think now I'm jungling between 5G and 2G and different technology. What is important today, if I look at industrial IoT, many people are using 2G and 3G. And if I look at the M2M communication, the machine-to-machine communication, clearly 2G was the preferred technology. The fact is, as the service provider are willing to get the frequency band back and use it for 5G, people are now announcing the end of life, or the end of, I would say, the end of life and shut. Question. Yeah, sunset. Sorry. Yeah, it's a typo. Thank you for that. So clearly, it's a sunset of 2G and 3G services. So if you start looking in Europe today, the trend is to turn off 3G services. Several countries have already done it. That means here, when you start looking at your configuration of the router, how do you prepare for that? So the first recommendation, very simple, the antenna. You have to make sure that the antenna you are using today on your platform can support the frequency band, the new frequency band that will be used for 4G and 5G. Like, for example, if I look at the dipole antenna from Cisco, you have first generation, which is stopped at 3 gigahertz in terms of high band. If you go now for 5G or 4G in different countries, we go up to 4 and 5 gigahertz band. So the first one, if you want to check your installation, are you ready to move? What kind of antenna do you use? The second one, clearly, if you look at the Cisco interface, we have been able to support 2G, 3G, and 4G. And the fact is, we try to attach to 4G, and if there is any issue, what we do, we fall back to 3G. And if we don't, we can fall back to 2G. And here, what does it mean if there is no more 3G services or just 3G services in some area, and you want to be prepared? The first one is on the iOS image configuration. You can force to all LTE only. So what does it mean? It means you will never fall back to 3G or 2G. Now, I know customer, we got customers saying, oh, in my location, I want to use 2G. 3G services doesn't exist anymore, but I don't want to use 4G because the 4G signal is suffering from interference. So what you can do, you can also force, if you want, the use of 3G only, and by 3G only, we really mean 3G and 2G. So that's the kind of configuration you can start considering. And by the way, some people are using IoT SIM card, and some of the SIM cards are not supporting LTE services. So once again, need to work with your service provider and make sure that you are getting with the SIM card, you can get access to 4G services as well. So that's clearly the 3 recommendations if you want to be prepared for sunset of 2G and 3G services. Now, if I look at the different pluggable as well, the fact is I talk about different category and different speed for cellular, and clearly it's coming across different 3GPP specification. So once again, when we look at 3GPP, we talk about the release number. And the release number gives you the information about what kind of capabilities the cellular network can do. So when we say, for example, 5G, 5G really means 3GPP release 15, 16, and 17. So this is where we are. And that means as well that when you start looking at the pluggable interface, the pluggable interface can support a given release and given set of features. So that's quite important here because, as you can see, if I start talking about category 4 LTE, I'm getting a downstream capacity and the upstream capacity. Now, if I look at the evolution here, for example, I go to Cat 6, I'm getting more downstream capacity. If I go to Cat 18, I got another level of capacity. What does it mean? It means here the module can do carrier aggregation and can aggregate multiple channels to provide more bandwidth. So here, there is a dependency between what the service provider can offer using the radio access network versus what the modem itself on the device can do as well. And that key reason, as I said, you look at the low end part of cellular technology. You can also go very low in terms of data rate. And this is where you have narrowband IoT, you have category M1. You see how much you get. And the reason they are white here is just because Cisco doesn't provide any modem supporting narrowband IoT or category M1 right now on our product. The other thing which is quite important, when we have been developing the industrial router, we make sure that the cellular interface is modular. And it's modular for one reason. Today, many of our customers will be using here in Europe the PLT GB. And the reason is because people are using 2G, 3G, or 4G. But at the same time, if you are planning to go to, I would say, more higher data rate or 5G services, you don't want to replace the full hardware. So that's the reason using the pluggable interface, we can just remove the card, you put your SIM card, and you go, and the configuration stays the same. Product stays the same. So that's quite important for us in terms of development. Now, something we are introducing here at Cisco Live is a support for LTE 450. Some countries, like Germany, Netherlands, Scandinavia, Norway, Sweden, Denmark, the regulator has, provided the 450 megahertz band for services, and the network most of the time it's a single network, single operator per country, and the network will be used as I would say public services like utilities, government agencies. So the benefit of the LTE 450 is very long, very good penetration, long range. The network will be dedicated to, if I look at utility, for example, in Netherlands here, the network has been built for utility. So it provides the services. And from there, you can start deploying and adding, I would say, additional cellular services for your deployment. The LTE 450, I would say there is an alliance for that. One of the key challenges with the LTE 450 is the fact that all the modem you can find on the market today, the analog filtering for the radio, generally start at 600 megahertz band and go up to 4 gigahertz band. So that means you need a specific modem to support the 450 megahertz band. And what we have done here, as I say, it's you have two bands, band 31, band 72, that's the one allocated by the regulator. You see the frequency band for downstream and upstream, but you see and the channel bandwidth. So the result of that is good penetration, but low data rate, and new kind of services. So that's the reason we are, launching on the market the new PIM for the LT450. Now, I talk about the 5G because this is the other evolution. What we see on 5G services, I try to summarize on this slide what a cellular network is about. If you look at the architecture, you start with the endpoint, your mobile phone, your router, your tablet, your laptop, whatever you want. You have spectrum, so somebody needs to get the spectrum. Remember, it's regulated. And from there, you have the radio access network, and then you have the packet core. That's the typical 4G deployment. Now, when we say 5G services today, as I said, 5G services from service provider is based on what they call 5G non-standalone or 5G NSA. That means here, you need to find endpoints that do support 5G NSA. I don't want to do any advertisement, but you look at, for example, your iPhone. If you have iPhone 13, 14, or it will support 5G NSA. And then you have the radio network. The radio network means now you have your 4G radio, and you have 5G radio as well. And then the packet core is still 4G. So what's happening is all the control plane, all the signaling is using 4G. But now, if you start generating enough traffic, the 5G channel will go up. And I will show you that on the iOS router later. And then the next evolution, so where we are, you can take any services today for 5G in Europe, it's 5G NSA from a service provider. And now the next evolution is you get here a 5G SA device, and this is where it's becoming challenging. Because when your device supports 5G, you need to start looking, is that 5G NSA or 5G SA? And is that 5G SA for which band? So you need to differentiate what's happening here. So that's the reason I put one of the websites which try to track which band is supported by which device for SA and NSA. But don't assume that because you are getting one device, the other, I mean, for one band it will support SA and NSA. No. And from there, you have your 5G license spectrum, you have the 5G radio network, and you have the 5G packet core. And one of the benefits of the 5G packet core is the fact that you can disaggregate the function. And I will show you later one slide about the architecture, because if you start, I mean, if you say, let's use 5G, private 5G, you need to think about network design. And everybody's, I would say, advertising 5G as being good for latency. So you need to understand exactly what latency means, particularly if you are focusing on your IP application. So now the fact is, we talk about 5G as technology, but what do we mean by private 5G? Private 5G, most of the time, if I look at people willing to deploy private 5G in Europe, like Germany, for example, where you can just get spectrum, it means a private network built on cellular technology, where you can acquire a piece of spectrum and do your deployment locally. And by doing that, it means 5G SA, because we don't expect people doing private 5G deployment to say, OK, I will deploy both 4G and 5G. No, they want to go directly to 5G and get the benefit of that. So that means here, the 5G endpoint, and that's clearly the main challenge today if you look at the industrial IoT, where people are willing to deploy private 5G, because they need to identify which endpoint they can use. The spectrum, the radio network. So spectrum is interesting because many countries in Europe now, the regulators has opened the, I would say, the auction for a piece of spectrum to be used for private network. And then the radio network, the access, how you build your network, and by the way, here, the packet core. So that's what we mean by private 5G. And we have partnered deploying private 5G with Cisco in different countries here in Europe. So now, what can you connect as devices? So I'm not focusing on mobile phone or the tablet. I'm just showing the router and being part of the IoT business unit. I'm not covering what enterprise network product can do, just focusing on the IoT. So whatever router we do today on market, I mean, if you go to the world of solution, you can see all of them. The cellular interface is modular. And from there, you can insert 5G. And these are all the bands we do support. So for Europe, the 5G interface does support 3G services, 4G services, and 5G services. But by 5G, we really mean 5G non-standalone. By offering new firmware upgrade and new iOS images, this summer, we'll be supporting 5G SA, standalone mode. If you are willing to do testing today for private 5G, then you need to contact me, and we'll see how we can provide the software image and the firmware for that. But that's clearly what we do support today. So that means you can start deploying your industrial router. So now let's review the configuration. The first key element of cellular is what is called a private access point name, or APN. It's just a text string. So the challenge is you need to know the APN, or for 5G, terminology is a little bit changing. It's coming DDN, but that's the same. You need to know the private APN or the public APN to connect to. So when you take your mobile phone, it's quite easy because the SIM card you are getting from your service provider will attach to a well-known consumer public APN. So most of the modem are storing the list of well-known public APN for the consumer market in software, so you don't need to define anything. You can directly attach. Now the fact is, when I start looking at industrial IoT deployment, nobody's using public APN. What you are using a private APN, meaning you will connect to, an APN or a gateway that the service provider will dedicate it to you as a customer. And the private APN name can be whatever they want. So it means the device itself doesn't know the name. You have to define it. Now, the reason is quite important because you define the APN, and from there, you can attach to the network. The fact is, the APN name, you can set it up on iOS, but the APN name is stored inside the modem itself. So even if you do a write erase of your configuration, but you get a PIM card, which has already been used by somebody else, you may have an APN defined inside it. So it's quite important to look at that. And the fact is, on the first generation of pluggable interface, we were only supporting one region. Like, for example, you have the PLT GB for Europe, you have the PLT AT or NA for North America. It's quite easy. You put your SIM card, it only works in one country, and you have one firmware. Now, with the latest generation of modem, the modem itself will support different regions. The modem itself will have different firmware. So the APN is stored on the modem per firmware. So if you are roaming, let's say, for example, you are coming to Europe with an AT&T SIM card, you plug the AT&T SIM card inside the modem itself, the modem will recognize the SIM card and will boot with the AT&T firmware, which may not be applicable to a service provider you connect to in Europe. So you need to modify that, and you have to make sure that the APN definition will be done accordingly to where you are. And that what we do support. So today on all the pluggable, we do support dual SIM card. So you may have, failover, and you may have failover between public and private network as well. And we can support what we call multi-PDN, meaning, for example, you may have one APN defined for public access, public internet access, and one PDN defined for the private access of your network. That's what the service provider can offer. Now, the fact is, the APN configuration is the first step you need to perform to get your modem attaching to the network. The challenge is when you do that, now think about zero-touch provisioning. If you use zero-touch provisioning with a router, either with DNSE or vManage, IoT FND, IoT Operation Dashboard, you can't get a configuration on your router. The configuration of the router needs to be scratched. But you need to define the APN. So that's we need to find a way. That's the reason we need to find a way to do the configuration. And that's the reason what we have done. In the previous iOS release, the configuration of the APN was done at the exec level. Now, we modify that, so you can do the configuration of the APN under the config term. And the benefit of that is because now, to do PNP, you can put a USB key with a minimum configuration, like I'm showing here. And from there, it means when the router is booting, scratch, the PNP process will get the minimum configuration from the USB key, will set up the APN, and now you can do the PNP process across cellular. So when you want to automate deployment, as I say, with vManage, SD-WAN, DNSC, IoT-OD, that clearly will be the requirement. If you want some documentation about the USB, the file format, clearly something you will find on the link here. Some recommendation on how the USB key has to be formatted, and the fact that the name of the file has to be this one. Now, what we have done as well on 17.9.1, we have introduced a new mode. So for people who are not looking at PNP or whatever, or maybe looking at PNP, but are using the web UI of iOS XE, what we do, when you boot your router, by default, you can access it with your laptop, get an IP address, and open the web UI for iOS XE. And from there, you have your day zero configuration. On the day zero configuration, we added a new mode we call cellular mode. What the cellular mode will do, this is where you can define your APN, private or public or for your private network. You define your APN, and from there, when you save it, it's saved in the modem, and then the configuration is erased, the box reboot, and from there you can do PNP. So we try to simplify the process, making sure that you can do zero-touch deployment, but setting the minimum configuration. Now the fact is, quite often, you need to go through the flow to understand exactly what's happening with the modem configuration, making sure it works. So what I have done here, I'm detailing all the steps. The first one is when you boot your box, iOS will boot. But then you need to make sure that the modem has been recognized and the firmware is uploaded. So this is where, if you want to do a show cellular hardware, so the example is on the 1800 platform, you see here all information related to the hardware and the firmware. What does it mean? It means the modem has been properly initialized. If you don't have any number here, it means the modem is not recognized, or it's not yet fully initialized. You have to wait for the number. The second step is making sure that the SIM, you have inserted the SIM, you can recognize it. So as I say, we do support two SIM, slot 0 and slot 1. So when we say here, active SIM equals 0, it doesn't mean there is no active SIM. It just means the SIM in slot 0 is active. And it will be slot 1. By the way, if you identify the SIM with if you authenticate the SIM with a PIN code, you have to do the PIN code as well. We have CLI command for that. And from there, you look at the firmware. As I say, on the new generation of SIM card, the Cat18, the 5G, the module is global. It's a module you can deploy in any world region. We have different firmware. So now we need to make sure that the firmware is loaded and the firmware is active. In Europe, I would say you have no issue. Firmware is generic GCF. You may care about firmware if you start roaming between countries, like you go to North America, where you may have AT&T or Verizon or T-Mobile. You go to South America, you go to Australia, you will see different kind of firmware. But Europe, the carrier certification is done using generic GCF. What we mean here by active or automated, iOS has a feature we call auto SIM. You put your SIM card, and the SIM card will recognize what kind of firmware should be loaded. So that's the reason I say only potential issue, you get a SIM card from US, you put it in the modem in Europe, it will be loading the firmware for the US carrier. So now we have the SIM card, we have the firmware. What is done is now the modem is activating the radio and try to attach to the cellular network. For that, where you can look at that, where you see, are you attached? And clearly, if you are not attached to the network, something is wrong, maybe the antenna, maybe the connectivity. You will see the number for the carrier. If for any reason you are using one SIM card in a different country, here it won't be home, but it will be roaming, meaning you are roaming between countries. And why is that important? Because if you deploy next to a border, you don't want to be roaming, because you don't want to receive the bill from your service provider because the modem was roaming. So once again, as part of iOS, we don't recommend doing that, but if you are close to the border and you think that you could be roaming, you may force the service provider to attach to. And here you have value, which is the mobile country code and the mobile network code. You may want to force them, making sure that the device will never connect to the service provider on the other side of the border. It's a matter of controlling the cost. And once you are done with that, you see here all the tracking information, the cell ID. So good information. We don't do that today on our management platform, but you can find many websites where you will see the base station radio from the provider, as well as the coverage of base station, the number of the base station, meaning you can do correlation between information from the radio network and information from the modem. And it's good to see when you have coverage, what does it mean here. Then you have the show radio, which gives you all information about the radio, which technology you are using. So for example, when I say 5G NSA, it means here you should see the activating ENDC, meaning the 5G channel has been established. You see the frequency band as well. And from there, you have a profile activated. So the profile is where you have defined your APN. You say, I'm connecting to the APN free telecom, for example, here, using no authentication and using IPv4 or IPv4 and IPv6 and IPv6. That's the profile. When you say that, profile is active, you are getting an IP address, you are getting your DNS server, and it means normally the next step is you can look at your interface, the show IP interface, and you will see the IP address, and you can start communicating. Now the fact is, when you do your configuration on iOS XE, you have few difference between iOS Classic and iOS XE. There is no more internal dialer interface. And the fact is, here, you may want to get the link being active permanently. So by doing that, what you can do, you can use a watch group here. What does it mean? It means you create a dummy IP address, and when you boot, the code will look at is the IP address part of my routing table? And if not, I will establish a link. And from there, I will keep the link always active. So that's the way we can do a permanent connection. And you may have your default route for V4 and V6. And you can see all the parameters here. From there, you have full communication. So if you want to do troubleshooting, make sure you go step by step, because that will allow you to find where there may be an issue. One feature we do provide on the modem as well, which may help you for management, is the dying gasp. What does it mean here? On the modem itself, and not on all the interface. I listed the interface here, but we have a super capacity or capacitor, which means if you lose power, we keep power on the modem for 10 to 15 seconds, and that allows us to send an SMS. So for example, here, you can say, OK, I put dying gasp. I'm sending to this number the fact that I'm losing the power on the device. So remember, we talked about industrial IoT, meaning the device may be in a remote location, like a secondary substation, and nobody is there. So you want to get information to make sure you can react. So now, key point, quite often, one of the first questions from the TAC is, what firmware are you running on your modem? So it's not only what is your iOS version, but what is the firmware release? The key point is, today, when you upgrade iOS, we don't upgrade the firmware. If you want to upgrade your firmware, you have to do it manually. All the firmware for all modem are posted on Cisco.com, but you need, this is the list of pluggable. So that means you need to understand what kind of pluggable, what kind of modem, and from there you can copy the modem file. Normally you may have one modem file. If I look at the 5G PIM card, on 4G most of the time you have two modem files. One is OEM and the other one is PRI. And you need to copy it on your flash, and from there you can perform the firmware upgrade. So that may be one of the action, one of the tasks TAC may be asking you to perform if you are running very old firmware release. So from time to time, during your maintenance window, it's good to look at what kind of firmware version is available from Cisco.com and make sure that if you start upgrading iOS, you start upgrading the firmware as well. So something that is, I would say, happening now, and we are getting more and more questions is, oh, do you support eSIM? So the challenge we have is, at the industry level, people are mixing hardware and software capability of eSIM. So eSIM, for me, means the hardware SIM. And once again, there are multiple generations of SIM card. So the SIM card, why is the SIM card important? Because this is a SIM card that will contain all information about the provider and your certificate for authentication. So the fact is you have multiple formats of SIM card over time. The big one, I don't know if anybody remembers the big one here, but where we are today on the pluggable interface, we have the macro SIM. And if you look at your iPhone, I'm pretty sure today you have your nano SIM, or you may be using eSIM. And eSIM at the hardware level means the SIM chipset is soldered on the board of the modem. And now the evolution, after eSIM, there is something called iSIM, meaning the SIM function will be done by the CPU of the modem. It won't be a separate chipset. So that's the evolution. This is where we are. Now the fact is, the key value of eSIM for most of the people is the fact that you can switch from one provider A to provider B. And that's the software feature. That's what we call EUICC. So the question is not to me, are you supporting eSIM, meaning the hardware, the embedded hardware, but are you supporting EUICC, which means I can do zero-touch provisioning and I can switch from provider A to provider B. And clearly here, we do support the EUICC feature on different pluggable because it's a software feature of the modem. And that means here, the benefit of that is you may be able to do zero-touch provisioning. So for example, we have one eSIM one EUICC SIM at Cisco. That's something we call Cisco eSIM Flex. And there is a session on that topic during Cisco Live. So clearly what will happen is here, you get all information regarding your certificate, the provider, and the upgrade can be made over the air. So now the question is, how many profiles can you store inside the SIM card? And the answer is I don't know, because it's dependent of which SIM card you are using, because they have different capability. Now the key point is, remember, if you go for private cellular, private 5G, now you need to handle the SIM card as well. You need to make sure you can buy the SIM card, do the programming of the SIM card, so now the SIM card will allow you all the endpoint to be authenticated on your private 5G network. So that's the reason it's quite important to understand that. Here you can see the EUICC software feature. What does it mean? It means I have all the components, but the challenge is now you have to make sure that you have the management system for the EUICC. Because, so if you are running public or private, the public provider, or I would say, if I look at the Cisco eSIM Flex, it means Cisco, the control center team, they operate the SIM card. They have agreement with a different service provider, because now you will be able to select your service provider and will be able to switch that. So why would you like to use EUICC? There are, I would say, two uses of it. The first one is the day zero configuration. You receive a device, and you have your EUICC, you have the SIM card with EUICC support, and now you just want to register to your, selected service provider. Now, there are two ways to do it. The first one is, if I look at the consumer market, for example, you have your iWatch, or any, I would say, watch, you have eSIM inside, you go to a website, or you have your mobile phone, and you do some action, meaning the user does an action that will provide the information for the EUICC. But when we start looking at industrial IoT, we don't want a user action. We want automation. So that's the reason, if I look at the way it works with the eSIM from Cisco, what's happening is the eSIM is registered on the control center platform, on the managed platform, cloud, with a minimum roaming agreement and a minimum set of data subscription. So now, meaning you can establish communication through whatever service provider is available where you deploy, assuming the roaming agreement. And from there, you get authenticated. And you can start downloading all the credentials for the service provider you are selecting. Now, so that's the day zero. And as I say, if you want to go more, go to the dedicated session or look at the recording for the session. Now, the second thing is what is called the day two, meaning you have been running on provider A, and you would like to switch to provider B for whatever reason cost or other reason, coverage. Now, the fact is, if you want to do it, you need a management platform. Because remember, if you say, for example, I'm running on provider A, and you want to switch to provider B, before you can download the certificate or all authentication for provider B, you still need communication through provider A. So the question is, are you willing to maintain two subscriptions at the time to do it? So that's the reason most of the people offering services, offering, for example, IoT SIM card, they do run a centralized management platform to avoid you to deal with multiple subscriptions. So what will happen? You connect to you will connect to the centralized management platform. You will select your new provider, and from there, it will make sure that you can download all information related to your I would say, new subscription. And from there, we can reprogram the EUICC information. So now you switch from A to B as a provider. So that's really the benefit of the, I would say, eSIM or EUICC, and that's the reason when people are asking questions, I always try to say, what are you talking about, eSIM or EUICC? And I know it's confusing. The industry is always talking about eSIM, but eSIM or EUICC means you can use any physical SIM and get the feature. But it's dependent on the modem, and it's dependent on the centralized platform. So the key point related now to the network design is you don't go, the first question we ask our system engineer or customer in a meeting is, okay, you want to deploy wireless, but to do what? Because I cannot give you any recommendation, any suggestion about network design and wireless technology if I don't know what you're looking for. And that's the reason we need to identify the use case. We need to identify the vertical where you are. And from there, we need to understand all the steps, I would say 1, 2, 3, before we can talk about 4 and 5. The first one is, what do you want to connect? What kind of device? If I don't know the device, for example, let's take your mobile phone. I say you can go for 5G, but if you have an old generation of mobile phone, you don't get 5G modem. Or if you get not the old one, the latest new one, you won't be getting 5G SA. So we need to understand exactly what kind of, I would say, device you want to connect. So that's clearly the first one. And make sure that you have the ecosystem, the ecosystem is there. So when we say private 5G, we mean private 5G SA. We need to look at, you want to connect AMR, AGV, or a camera, or whatever. Let's make sure that we have the modem for that device. From there, what are the network characteristics you are looking for? Latency, data rate, reliability, scalability. So we need to understand exactly all the parameters. So from there, we know exactly what to expect. Remember, if I look at most of the public services for cellular, the data rate is asymmetric because it has been designed for mobile phone user, where you don't expect a lot of traffic upstream, but if you are streaming video or whatever, you expect a lot of traffic downstream. Now, when you deploy cellular for industrial IoT, I'm expecting you may have a lot of traffic upstream. Let's say, for example, if you have a video camera, HD, doing monitoring of your production line, it's upstream traffic. So this is why for private deployment, most of the time you will have symmetric boundaries. The way you will set up your radio network, you will be looking at how to set it up for symmetric boundaries, which is not what you are getting from public services. And from there, what kind of deployment do you want to do? Where are you located? I mean, if you say, I'm willing to deploy in Germany a private network, let's do it. I mean, you can get your bandwidth from the regulator. If you are in a given country where there is no available spectrum for you for private deployment, private cellular won't be an option. So clearly, this is why we need to understand exactly where you are. Is that indoor, outdoor? Is that for, connecting devices, like, for example, in a manufacturing use case, or is that for just backhaul? We need to get all information. So now, if we cover 1, 2, 3, it's quite obvious to select one technology. I mean, we can say, you are looking for very low data rate, let's say a temperature sensor sending one information every 15 minutes, could be LoRaWAN in our portfolio. Or it could be wireless ART or ISA 100 if you are working different industrial vertical. Now, if you really need, if you have the spectrum, if you have high data rate, cellular, Wi-Fi, curb, once again, depend on what you want to connect. And the last one, total cost of ownership. How much does it cost? What is the cost of the spectrum? What is the cost of the device? What is the cost of the operation? That's what you need to factor to take decision. So that's the reason here we are not saying one technology is better than the other one. Whatever you want, as long as it fits your requirement for the use case, it's good. But make sure you go through all the steps to understand what it means. The fact is, as I say, the bandwidth for cellular is asymmetric and dependent on the frequency band. So it's not like, I would say, Wi-Fi or whatever, or Ethernet, where you say, you have 1 gig, or you have 100 meg, or you have 10 gig. No, here it's clearly dependent. Which frequency band, how much channel bandwidth, what modulation, are you doing MIMO or not? So that's the reason. Nice tool on the website where you can go for, I would say, LTE bandwidth. You can go for 5G bandwidth. You put your band. So here, for example, I want to look at this band. I'm getting, so it's band 48. 48 is North America. That's CBRS. I'm getting 20 megahertz of channel bandwidth. I'm using the best modulation for downlink and uplink, and the tool is giving you the maximum data rate you can get from the network. So, and you see here, it's upstream and downstream. And you can do exactly the same for 5G. So here, I'm using band 78. I'm getting what, I don't remember, I think 100, it should be 100 megahertz of channel bandwidth, the best modulation, and you know how much you can get at the physical layer of the network. And once again, it's a physical layer of the network. Remember, it doesn't mean it will be what you'll be getting at the IP layer. I talk about carrier aggregation. So once again, the way on LTE you can increase the data rate, it's not dependent from you, it's dependent from the radio access network. What the service provider can do is by doing carrier aggregation. So on 4G, the maximum channel bandwidth from the carrier is 20 megahertz. So that means here, for example, you get 20 megahertz, and you will be getting X as bandwidth. Now, you want to do more, what you can do is you can start doing carrier aggregation, meaning the service provider will have multiple channel, multiple band, and now you can aggregate that to provide more bandwidth. And by the way, when you go to 5G NSA, what's happening is the carrier has a 5G radio network in place, and now we can aggregate everything, all the channel, and get the maximum. So that's the reason what I put here is what are the pluggable supporting carrier aggregation today. So one of the challenges with carrier aggregation is how do you monitor it? How do you know if carrier aggregation is activated or not? There is only one way to do it. CLI and the show radio detail. The detail is quite important. And this is where you can see when you are generating traffic, meaning traffic has to go through. Because remember, carrier aggregation may be activated, but not all the time, because the service provider is willing to preserve resources on the radio network. So that means the aggregation of carrier will be activated when you have enough traffic going through the network. So that means here, I'm looking at what I have 2 secondary channels for LTE, and I have 1 5G channel. I'm on 5G NSA, so here I can see that I have band 78 and using 90 megahertz of channel bandwidth. So this is the aggregation of all that will give me the, I would say, the total data rate and network capacity. So that's how you can look at the parameter. And by the way, you have radio information as well for each of the channels, because you are on different bands. I was only covering the lower layer of cellular, but most of the time, what you do on cellular, you're also running IPsec. You're also running VPN. And that means we have technology with FlexVPN or SD-WAN where you can say, OK, I'm using one VPN tunnel, and if this tunnel fails, I can switch over and get other. There was a very good lab done on Cisco Live on how you can, I would say, configure the FlexVPN tunnel. So that's the reason I did I put the recommendation here if you want to look at it. So one slide is missing. Okay, this is a slide. Okay. Now, the last topic is about end-to-end latency. The reason I put the slide here, I want to demystify a little bit of latency. I mean, when I'm reading the press about 5G, people are claiming, oh, 5G will do 1 millisecond latency or 10 millisecond latency, and it will solve all the issue of the planet. No. The latency is a matter of network design. So you are the one designing your network, or you're working with your partner to do it, or with a Cisco engineer. When you design your network for latency, you don't care about radio latency. You care about end-to-end IP latency, because your application, your use case is running on top of IP. So what is important is this is a view of a 5G network. But I'm taking 5G as an example. I'm a little bit, I would say, aggressive here, but you could do exactly the same on Wi-Fi. You could do exactly the same on Curb. I mean, the principle for design is exactly the same. You have the overall network, end-to-end, so you have a data center, or you have cloud services, you have internet on one side, and on the other side, you have your device. And for your use case and application, you must respect a given latency. So for example, if I'm looking at the AMR here, the maximum latency is 70 milliseconds. That's what I must respect if I want to get the AMR properly working. So that means now I need to split the latency across the path of the network. So here, if I look at the 5G deployment, I can see the radio network. And one of the benefits of the 5G radio is the fact you can disaggregate the function. I mean, everything could be running on the base station, or you can disaggregate the function of the base station between the radio unit, the distribution unit, and the centralized unit. And then from there, you have the control plane. So the control plane is what is called the CPF, where you have all the mechanisms for authentication and other, and that can be part of the cloud. And then you have the UPF, or the user plane forwarding, meaning this is where you are ending the tunnel. I mean, remember that the cellular, you have a MAC encapsulation, a GTP protocol. This is where if I put an IP packet here, the packet is encapsulated over GTP up to the UPF. And from there, I'm sending a native IP packet that I'm routing on the internet or to the data center or on the enterprise network. So that means when I start looking at end-to-end IP latency, I need to make sure that I understand the full path here. Now the fact, all the number you can read about 5G latency, it's about the radio network. It's about this part. So that's the reason I say your role as designer, as a network designer, is make sure you understand the full path here. Now, what I try to show is with a red, green, and arrow is if I want to look at the latency total, let's take the blue one. The blue one is my device is communicating with a cloud application, with the cloud services. Meaning I'm sending the packet, the IP packet from the AMR, I'm sending it through the radio network, and here I'm reaching my centralized UPF, and I'm putting the packet over the, I would say, fiber, whatever you want, or cloud services, and from there it will reach the application. That's my end-to-end latency. Now, if you are doing private 5G in a manufacturing environment, and you want to get the lowest latency as possible, it means now you have to make sure that the UPF function, you can distribute it on your site as well. Because now the latency will be the red one. I go to the radio network, I go to the local UPF, and I can reach my system. So, as I said, same with Wi-Fi. You have your WLC. You can consider that the UPF is a little bit like WLC, where you are putting your IP packet out. So you want to decrease your latency. You are manufacturing use case for private 5G. Where do you position this one? And then we have people willing to do peer-to-peer, like, for example, a PLC to a camera or whatever, or 5G. This is the red arrow, the green one. You send your packet, but it's a tunnel. So there is no direct switching here. You need to go to the UPF, and UPF will be the switching to send the packet back to the network. So now I do communication here. And I can do it at the IP layer. The spec, the 3GPP spec, indicate how it could be done at the Ethernet layer. But if you want to do it at the Ethernet layer, then the UPF function needs to provide some layer 2 switching capability. And today, I'm not aware of any, I would say, UPF doing layer 2 switching. So most of the time, what we do run something like VXLAN on top of it. So we have the IP network, we do VXLAN, we can transport layer 2 traffic, and we can switch back. And there is a very good session about VXLAN over FlexVPN as part of the IoT track. So that, as I say, as a network designer, look at latency as end-to-end for IP and make the proper network design. Don't be religious about technology. Pick the best one for your use case. So key takeaway, I'm pretty sure that if you are doing industrial IoT, you will have to consider cellular as technology. And make sure that you understand you have different, generation of cellular, and make sure you understand which one you can use and what are the parameters. And from there, let's go through a good network design session and make sure that we are successful with your deployment. Thank you for that.